this kind of summarizes it here. So I have okay. So this is a view of the Earth in the view in the projection called ortho. We call it ortho in OCE, and it just shows it's basically what the Earth would look like with a very long lens from a very great distance. If you're in photography, you know what I mean by that. But if not, it's just sort of like with the Earth shape. And you can see a problem down here if you're familiar with the geography of the Earth, that the coastline of Antarctica, this one down here, the southern part, is incorrect. And this weird straight line, all that's happening is that there's some points on the opposite side of the Earth. I hope you can see that there's, I hope you know enough that we're not seeing the whole Earth here, that there's lots that's on the opposite side. Okay, and some of those points are being connected up, and that makes this weird line here. I'll call that an anomaly, and there's other anomalies in here as well. There's an anomaly in here. There's probably 3 or 4 anomalies around. So my current way of thinking of how to get rid of this is I pick a point that's in the center, actually just in the center of the plot. And to be honest, that would be ruined if you had weird margins. Like you could have a really wide margin over here and a really tiny Earth. I don't know why you want to do that. You might want to, and this method wouldn't work. But I could change that anyway. It doesn't matter that much. Okay, so I pick a point somewhere here, about where the mouse is, maybe just at that intersection. 0 lon, 0 lat in this projection is at the center. I pick a point there, and then I draw radial lines, some number of them. I think 128 is what I'm using at the moment, but some number of radial lines. And then I do a bisection and I draw it out to the hypotenuse distance. So it goes to right up to the corner here and past the corner at the edges. And I know that the center point is on the Earth, and possibly the other one is not on the Earth. If you zoomed up, it would be on the Earth. But anyway, imagine that in this scale here, it's not on the Earth. So I do a bisection search and I find a point which is just inside the sort of disk of the visible Earth, if I can say it that way. And I'm drawing that here in blue. That's step 1. And then I go into step 2 here, and I'm just developing an algorithm. None of this is in OCE yet. This is now showing a kind of a coastline, is with plot coastlines in OCE. So it's really not using projections, just lon and lat, but scaled so that a circle at the equator would be a circle on the graph. That's all that is. Okay, and I've done a green, I don't know what that color is called, pink, I think, pink color. I'm not colorblind, but I can't remember the names of colors. So I've put South America and part of Central America too in that color. I've just selected them because I know there's a problem. And how do I know that? Because I've plotted this. So what I'm doing here in this one, I've used the SF intersection algorithm, which as of a few versions ago, I don't know how many versions, is using the S2 system as a sort of underpinning. And that does intersections on a sphere, not in on a sphere, not in a rectilinear space, not on a planar system, but rather on a spherical system. Okay, and that offers a potential, I think. So, and so what I've done is I've done the intersection, and I've plotted them again in a projection, the ortho projection, just like the left panel. You can see it here, and now it looks like I'm color coding everything else by blue, not by gray, and I'm color coding this one by red and not by pink. I have no idea why. Now let's just look at the good. The good. Antarctica seems to be fixed. You know, this craziness here, all fixed. This craziness up here, not so much. And in fact, there's something that's in gray here and it's come out in white here. So it even maybe got worse there. And now we come to our neck of the woods. I mean, I'm speaking to you from here in Nouvelle-Écosse up in Canada. But if you look, this is Brazil. This place here is Brazil. And where the mouse is presently situated, I'll stop moving it. Where the mouse is presently situated, that's in Brazil. And I think you can see this funny little triangle. No, I can't zoom this. Oh, I could zoom that. Can I zoom that? Okay, I can't. I don't even know why that's not zooming. Because it's a quartz window. I'm sorry, I can't do it. I've been looking at this code for too long. Okay, so you see this weird little triangle. So that is not good. That's not what I want. So there's an error coming in. It's kind of an error coming in here as well. And as I say, up here and even over here, that's not quite right. Now I'm showing you how I've fixed the problem. So what the problem is that at this spot, it took me a little while to figure this out. At this, and now I'm in easting and northing. So this is in meters, easting and northing. There's 1,000 kilometers, 10 to the 6th there. So there's a big jump. And the problem is that OC at the moment, in order to try to fix this sort of problem, finds a big jump and it does something funny at a big jump. And it's seeing that this is a big jump. So long distance relative to the other distances nearby, I guess is how I have to find that. And consequently, it was drawing, it was just doing something weird. And how am I going to fix it? I will temporarily, I fix it by setting an option called OCE Developer EOW Edge of World, or you, David. If you don't know what I mean by that, you should watch Schitt's Creek, best show on TV. Well, it's not on anymore, but best show made for TV. And if that is actuated, if I've made that definition, then when it gets into, now I'm in OCE code called map.r. This is a function that draws polygons for maps. And okay, there's some preliminary stuff of extracting the data. It doesn't really matter. You could skip that. This is the core thing here. You'll see that what I've done, prior to this, we had these lines were being run. I was running a function called bad fill fix 1 and bad fill fix 2. Who knows what the heck they were doing? It's just me trying ad hoc crazy things that I guess worked for some domain, and then, as you can see now, caused a problem in another domain. What I've done here is I've nulled them out. So if that thing is defined, we skip that step. And when you skip that step, wonderfully, you get that. So I'll go back. So that's Brazil properly. Oh, I'm not drawing the rest of the world. Not like a plate tectonics where everything else gets destroyed. Brazil gobbled everything up. It's not that. But I'm going to go back. Just put your eye on that thing and you'll see. Yeah. So that was Brazil cut off. That was the prior code. And now the code with this new thing looks pretty good. Well, I think this is basically the end of the video. What I want to say is that I'm making some progress on the mapping problem that I think is maybe 2, 3, 4, I don't even know how long it's been a problem in OCE. And really the way it's going to work, and I do think it's probably going to work, I have to get rid of some other crazy ad hoc code that I had and instead just rely on this new fact that polygonal intersections done in SF. We'll be using the S2, I don't know, framework, I guess. And this will do intersections on a sphere, which is exactly what we want. Thanks for listening. Bye.